All right. I know that we've gone over this before, but honestly, the importance of this and the format, and I know that the last two videos have been wearing you out about format, and your work on surface area looked absolutely fantastic. The organization of your work, that's the most organized I've seen your work ever. So, congratulations on that. Greatly appreciated. It's going to pay off in the end. Um, I know that certain times of a teacher telling you or an adult telling you to structure things a certain way is like an interpretation of them trying to control a situation. But honestly, whenever it comes to mathematics, organization of work and coming up with a strategy to organize work, as well as utilizing the universal way that everyone organizes that work, is basically just learning the semantics of a language. And that's exactly what you did on your surface area. So keep on utilizing that workspace and then having that separate sheet over there to have all your side stuff. So the sixth grade emphasis, model and solve one variable, one step equations. We're going to go over that, but the purpose of that is to create a foundation. I believe you already have it. I just want to make sure that we're emphasizing so we can go into higher level concepts. So currently where you're at is solve one and two step equations. We're going to do that as well. But the thing that we're going to be jumping into is modeling and solve one variable equations with variables on both sides, which would be multi-step equations. We're going to get there. So this is the first part of that. Think of this as we agreed to build a house together. This is us laying the foundation. Okay? So I think it's important to go over the origination of solving equations. It's like why does this process work the way it does? So if you think back, like my son, for example, he's 8, and he had these fact family triangles to do, and it was like 7, 5, 13, and then you had to find the appropriate bar that would match that, and then write out the fact families about how using those three numbers you can arrive at the answer being one of those three numbers. So the example that I've got over here is basically what you started with, like when you first started learning math as a little kid. You had seven, you probably had like seven things in front of you, and you were able to count them 1, 2, 3, 4, 5, 6, 7. And then you had three other things, and you had two groups. You had 7 and 3. And then you'd count them all together, and you'd go, oh, okay, I have a total of 10. This is where the beginning of algebra was coming in. X equals 10. X was the thing you didn't know, but now you do know it because you put 7 and 3 together. So this is us using PEMDAS, the order of operations, a universal language that's accepted anywhere on the entire world, regardless of what language you speak. This was the process we went through. Were there parentheses? No. Were there exponents? No. Was there multiplication or division? No. Was there addition or subtraction? Yes, addition. That's what we did first. Simplified it. We got 10. 10 equals X. The reason that I put this here is because I want you to see that this says 7 plus X equals 10. So you can see that we have 7 in yellow. We don't have 3. Now, I know that you're sitting there going, well, I can count it, and it says 3. Absolutely. But what we're doing is taking something so simple and representing it in a different way in a fact family and representing it algebraically. So we had this one to start with, 7 plus 3 equals X. Now we have 7 plus X equals 10. We're just reviewing a fact family. Okay, so we had 7, and we're going to add something to it to get 10. This is where you would go backwards. So we already had the operation. We didn't have a piece missing over here. But whenever we take a number out and we have the answer, we got to figure out what was added. And the way we figure out what was added is by taking it away. Whenever we take it away, it undoes, it will undo what we did previously. So if we had 7 added on to x, let's just take 7 away. That goes to 0, and we just do it to both sides because it's an equation, because it affects both sides. X equals 3. This is an algebraic representation of how to solve a one-step equation. And what we did was we started from here and we went up because we had a variable and a problem in an area where we couldn't do the math. See, we had 7 plus 3. We can automatically do that. We can combine those two things, but we cannot combine 7 plus x. This is where the algebraic ideas come in and solving a problem in reverse. Whenever you're sitting there going like, I can't do 7 plus x. Cool, let's PEMDAS in reverse. Let's do everything that we see in the opposite. So we started with addition, subtraction. We didn't start with parentheses, exponents, multiplication, division. We started with addition, subtraction, and we were working our way backwards. Working your way backwards using PEMDAS will make more sense when you get into multi-step equations. This is the most simplistic example I could possibly provide. So this is the origination of solving equations. And we'll continue to review PEMDAS in reverse as we solve. So the same process. What I want to do is I'm going to go through each one of these, but as I go to the next one, I want you to pause the video. I want you to match the format. And I know I haven't done one yet, but you should know the format. The things that I'm including whenever I'm writing are the things you should have on your paper. If you have any computation work that needs to be done on another sheet of paper, please do not muck up your paper by doing all the work and scratch stuff in the area that you're providing your answer. Do it in a separate spot. If you want to use a calculator, go for it. I mean, whenever you get in 8th grade or 7th grade doing 8th grade content, you're going to be using a calculator. So you obviously know how to do computational work by hand. That's not a question. So let's save ourselves some time. If you feel like using a calculator, go for it. So pause the video and rock this one out and see what you come up with. Okay, so I am a stickler for format. I know that you can look at this problem and say, okay, something plus 3 equals 9. That's not a brain buster. All right, the answer is 6. I'm just going to go ahead and write x equals 6. That's not the point, okay? The thing that we're doing right now is we're understanding format and procedure. So what operation? These are the questions I ask myself, and these are the questions I ask every single student whenever we're solving any equation. What operation do you see? Okay, well, I see addition. And it's important to understand the nuances in deciphering what operation is in a problem. Like, what are you seeing? And we know that because we can't do x plus 3, that means we're going to have to solve it in reverse. So that means x had 3 added onto it. So that means what operation was adding? What are we going to do? Subtract, because we got to work it backwards. So let's get rid of that 3. One of the main rules in algebra and chemistry is balancing equations. What you do to one side affects what happens to the other. Otherwise, it's no longer an equation. So this is the format and example of what we're working with. We identified that 3 was being added onto x, and now we have to take 3 away to understand where we were before we added 3. So this will drop straight down, x, and 3 take away 3. This is always going to be 0. So it's going to be 0, and if you're using multiplication or division, it's always going to equal 1. So this is just the equal and opposite powers, understanding order of operations yet again. There's only one operation, so this is the route we have to go. You don't have to rewrite 0. The whole intention of what we're doing is to get rid of this. So you can rewrite the equal sign. 9 minus 3 is 6. That is us rewriting it. X equals 6. So that is the algebraic proof. This is what you should have on your paper. Notice there's no work on the side, nothing like that. Next one. Take a moment Go for it. Okay. Now, again, nothing crazy. We know that something minus 3 is 9, right? I'll just go ahead and tell you it's 12. 12 minus 3 is 9. All right. But that's not the point. The point is us going through the process, prompting ourselves, organizing our work. So you can see that I'm dividing the problem in half. Whatever happens on one side of this dotted line has to happen on the other side of the dotted line. That's what makes it an equation, equal. What one side is the other side. That's why they're equal. So what operation? I see subtraction. So I know I can't do x minus 3. I don't know what x is, so I'm going to have to work in reverse. I'm going to add. So I see minus 3, so I'm going to do its opposite, plus 3. Drop my x straight down. This is going to 0 out, because anytime we add opposites, it's going to be 0. 9 plus 3 is 12. Proof of what we were doing algebraically. So there is the rewriting. Rewriting is going to come more into play as we move into two-step and multi-step equations and inequalities. If you have something different on your paper, I really want you to focus on the next one, adjusting what you're writing. Give this one a shot. Okay, so I think it's very interesting that in school, you're dealing with fractions for quite some time before you ever acknowledge that it's actually division. You can see that this says x thirds. You have x third equals 9. All right, well, that doesn't make any sense because it's actually a division problem. And the reason that symbol, division, looks like that is because that is a number and that is a number. Those things have values. And that's what makes a division problem. Division problem, that the symbol for division is a fraction. So what operation are we looking at here? Anytime you see a fraction, you know you're dealing with division. I can't take x and divide it into 3 pieces. I don't know what x is. So this is where we go in reverse, and we're going to be using multiplication. Notice I did not use an x. Cutting this thing in half. So if I'm dividing by 3, the opposite is to be multiplying by 3. And if you're sitting there going, well, how do I know what side to start on? Because when we get into two-step and multi-step equations, that's going to bring in an additional thing to prompt you. So right now we only have one side where something's happening, and that's x and divided by 3. 9, there's nothing we can do. There's no opposite operation. It's just 9. 9 is just chilling. It's like, what's up, 9? So we have division. We're going to do the opposite and do multiplication. If you have something divided into 3 parts, and then you multiply it by 3, that would be a third, a third, a third, making it 1. So 1/3 plus 1/3 plus 1/3, or 1/3 times 3, will give you 3/3, makes it 1. So you could think of this as, I'm just going to drag this over here, 3x times 3, because what you're actually doing is multiplying by 3 over 1. And then what's 3 divided by 3? 1. And that's what leaves you with x. So just know that whenever we're multiplying by the opposite of the operation, that's the idea that's happening. So this leaves us with x. See, that 1, 1. Anytime you see a variable, there is always an invisible ghost 1. If there's no coefficient, the number in front of the variable. Do you have to have the 1? No, because honestly, if you see an x, how many x's do you see? I see 1x. Okay, enough of that. What you do to one side, you got to do to the other. So just so you know mathematically how this is working, you got 9 over 1 times 3 over 1. That gives you 27 over 1, and that's 27. 27 divided by 1 is 27. So taking this answer, plugging it back in, 27 divided by 3 equals 9. That's true. This is us rewriting right here. So this stuff right here is what I'm talking about not having near your work. This is just me providing explanation as to why you're doing what you're doing. and how math is working, because these are called shortcuts. The things I have circled in the purple highlighter, those are the reason where those shortcuts come from. All right, give this one a go. And by no means am I trying to say, hey, dude, you're struggling with this, and this is us building a foundation. That's all. So what operation? Number next to a variable. So that's the coefficient next to a variable. And we know that whenever we don't see an operation between a number and a letter, that means multiplication. We have three x's, 3 times x, which gives us 3x. So what operation? I see multiplication. Notice I did not use an x to represent multiplication. I used a dot. The opposite of that is going to be division. All right, so if I'm multiplying by 3, that means I will divide by 3. And you can see a relationship about where this is already coming up. See, look, right here. This is just the reverse problem of what we did before. And we do that by 3. What happens when you divide 3 by 3? You get 1. That's why we end up having 1x. Like I was talking about earlier, having equal and opposite powers. If it's addition, subtraction, it equals nothing, which means we got rid of it on that side. If it's multiplication, division, it means we're having it equal 1, which means that we're working backwards. Instead of having 3 of them, we undid it, and now we only have 1. So 9 divided by 3 is 3. This is us rewriting a one-step equation and proving our answer. 3 times 3 is 9. Two-step equations. So this is where a greater emphasis on doing PEMDAS in reverse. So if 9 were our x, and we actually had the answer for x over here, like 2 times 3 is 6 plus 3 is x, then we'd be able to solve that and say, hey, it's just equal to 9. We don't have to do anything in reverse. But I don't know what x is, so that's why the process is going to be solving in reverse. So I'm going to go ahead and write PEMDAS. And we're going to start with, do you see any addition or subtraction? And of course the answer is going to be yes. You start with your weakest power first. If things are being added on, we want to remove those before we try to figure out what it was being multiplied or divided by. So there's the add or subtract. I'm going to acknowledge that we're adding, and we're going to do the opposite. We have to work backwards. You got to get rid of that plus 3. That way we can figure out what 2 is being multiplied by. So minus 3. And this creates our 0 pair. We have 3 positives and 3 negatives. That's going to give you nothing. That's exactly what we want. Now we're left with 2x. Notice I'm dropping it straight down from where the original problem was. I'm marking out the things that I'm not going to rewrite. That includes the operation that I used. 9 minus 3 is 6. This drops us straight into a one-step equation. Everything we just did. So we rewrote it. Now we jump up to the next step of PEMDAS in reverse. All right, so do you see any addition or subtraction? No. We got rid of that. Fantastic. Do you see any multiplication or division? Yes. I see a coefficient by a variable. That means multiply. 2 times x. So I see multiplication. That means I'm going to do its opposite, division. Notice I'm setting this up like a fraction. 2 divided by 2 is 1. I'm going to drop that x straight down. 6 divided by 2 is 3. Just like I talked about in theory about what x would be if I were to not have 9 there. 2 times 3 plus 3 equals 9. Following order of operations, 6 plus 3 equals 9. Check. So you can always substitute that back in for x and check your answer. Just make sure you're following order of operations when you're solving a problem forward. When you have all of the information, PEMDAS forward. When you're missing something like a variable, PEMDAS in reverse. All right, give this one a shot. Okay, so what I'm going to do is I'm going to move through this process without doing extra work everywhere. I want you to see how clean these problems can be, and then I want us to continue to replicate this. There will be problems with nuances that come up, little details that weren't included before, and that's where you're going to kind of struggle. And I want you to struggle, and I want you to come up with questions. I want you to have a question. I want you to make a mistake. I want you to have the work. I want to see it. I want to go over it, and then I want to point out where the mistake was being made, and then we can build off of that. So adding and subtracting, I see adding, so I'm going to go ahead and put adding. Got to work it backwards because I have an x in my problem over here. 2 times something plus 1 equals 3. Got to get rid of that plus 1 first. So minus 1, dropping it straight down to, now I rewrote it. Now I'm doing the opposite. I see a number in front of a variable. That means multiply. So I will be dividing. Divide by what is being multiplied. 2 divided by 2 is 1. X equals 2 divided by 2, 1. That is the cleanest a problem can be. That is you representing everything is equal and opposite values, working a problem backwards algebraically. X equals 1. 2 times 1 is 2, plus 1 is 3. Give this one a go. Okay, I'm cutting my problem in half. I really am a stickler about if you do it to one side, you have to do it to the other. Otherwise, you're going to not be successful. Do you see addition or subtraction? Cool, let's switch it up. I see subtraction, so that means I'm going to be doing addition. Okay, and so I see plus 3. Oops, I'm going to do that to both sides. Clearing up this problem, cleaning it out. Now we're down to a 1 step. I just rewrote it. Now, is it multiply or divide? Well, we already reviewed that a fraction is division. So identifying the pieces is the hardest part. We are going to multiply those thirds by 3, and we're going to multiply 4 by 3. So that's going to give you 3x over 3. So just know that this is always going to drop you down to 1x. That's the whole reason why you're doing that. 4 times 3 is 12. By no means am I saying this is difficult or if I'm saying it's easy. I'm saying that we're establishing a format so we can build from it. 12 divided by 3 is 4, minus 3 is 1. All right, go ahead and give this a go. All you should be looking at this point is it matching up? So I saw addition, so that means I did subtraction. I rewrote it. Is it multiply or divide? It's division. I'm going to be multiplying times 4 times 4. X equals 12. So 12 divided by 4 is 3 plus 1 is 4. All right, and now we've got another one. Go for it. All right, let's take a look. So add or subtract, it's add. See subtract. So I'm going to subtract from both sides. It goes away. X divided by 3 equals 4. I rewrote it. Check. And then multiply or divide, I see division. So I'm going to do multiplication. Times 3 times 3. X equals 12. 12 divided by 3 is 4, plus 1 is 5. Give it a go. Okay, so I'm knocking it out in half here. Minus 2, I see adding, so I'm going to do subtracting. 0 pair. X divided by 3 equals 4. I rewrote it. Check. Multiply or divide, I see division. So I'm going to be doing multiplication. Times 3 times 3. X equals 12. And you're sitting there going like, dang, did you make all these x equal 12? Yes, because I want the answer to be simple. I want the process to be the thing we're practicing. So 12 divided by 3 is 4, plus 2 is 6. Give it a go. I see addition, so I'll be doing subtraction. X divided by 4 equals 3. I rewrote it. Do you see multiplication or division? I see division, so I'll be multiplying. Times 4 times 4. X equals 12. Yes, 12 again. 12 divided by 4 is 3 plus 1 equals 4. Check. Last one. Okay, this one looks a little different. I just wanted to kind of throw a curveball in at the end. So the operations that we see, they're still the same. We still see addition, we still see division. The things that we have to focus on are PEMDAS and reverse. All right, what's being added? 1 is being added. Okay, so I see addition means I'm going to subtract minus 1. That's how you get rid of a positive 1. You take away 1. Rewrote it down to a one-step equation. X divided by 4 equals 3. So now I see division. I'm going to do multiplication. And guess what? It's 12 again. So here's the only thing that switches it up on this. Whenever you're checking the problem, like you're substituting 12 in for x, this is where order of operations, since you have all the information, you don't have a variable. You can do order of operations. Do you see any parentheses? No. Do you see any exponents? No. Do you see multiplication or division? Yes, do that first. 12 divided by 4 is 3. Do you see any addition or subtraction after that? Yes. 1 plus 3 equals 4. Check. Please make an attempt at the work, and please send any questions or incorrect work, anything. I want you to try and make it to the end. And if you sit there and go like, I just don't know, then put a big circle around the problem, or put a big star around it, or whatever. Christmas lights, do whatever you need to do. But I want to acknowledge that some of them are going to be difficult.